Okay, so question 13 from the homework we wanted to have a look at. A particle is projected from a point on a level ground with speed u and angle elevation alpha. The maximum height reached by the particle is 42 meters above the ground, and the particle hits the ground 196 meters from its point of projection. Find the value of alpha and the value of u. I'm very, very pleased you picked this question out because there's a clue or a tip I want to give you with this that I think many of you may have done or possibly may not have done, which I'd like to highlight because I think it's a good way of doing this question. Now, it says that a particle is projected from a point on level ground with speed u, angle of elevation alpha. The maximum height reached by the particle is 42. This distance along the ground, what do we sometimes call this distance along the ground? Range, good. This range is 196. Find the value of alpha and the value of u. Now, I should imagine some of you have done this question, splitting it as a u cos alpha and a u sine alpha like this. What you can do is if you find u sine alpha and u cos alpha, you will eventually come up with something like u sine alpha equals blah, 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 u cos alpha equals blah, blah, blah. Who can think of the best way of finding these, of using these two things? You can divide them to find out what tan alpha is, and then you can find out what the u part is. Now, that's one way of doing it, but or you can square them and add them to find out what u is. But if you want to find out what tan alpha is, you can divide them. Now, some people don't like doing that. And actually, in this question, what you may like to do, and which is probably what I'm going to recommend doing here, is I would recommend calling this one x and then this one y. Even though that sounds like we're not going to be finding out what u and alpha is. If you think about what this triangle is, if we know that the hypotenuse is u and you find out what x and y are, that's enough information to be able to find out what alpha is. How would I find out what alpha is?
Trig.
You do trig. You would do the y divided by x and do the inverse tan. Look, it would be that one divided by that one, and you do the inverse tan. And if you want to find out what u is, you would do x squared plus y squared equals u squared, which is this one squared plus this one squared equals u squared. So it's the same thing. However, what I think you will prefer when doing this question is instead of constantly writing out u sine alpha and u cos alpha, you just write down x and y, and it's just nicer to look at and a little bit less confusing. So if you do it this way, it's perfectly fine. I'm not saying you shouldn't, but I'm going to do it with x and y because I sometimes find it easier to keep it separate, put it back together at the end. Okay? So which one do you think we should consider first, vertical or horizontal? Okay, so we're going to have to do some vertical motion. And the thing I know about vertical motion, which bit do we want to tackle? Which bit are we going to use? Max height. Okay, so if we're going to consider upwards as positive, our initial speed is y. The maximum height is 42. The acceleration is minus 9.8 because it's going downwards. And what do you think I'm interested in? And we know that the final velocity is 0. And we're going to also be interested in t as well. Because remember, t, what did I say about t? Very good, Amara. T links the vertical and horizontal. So t is the bridge that takes you between the two. But look, I've got 4 things, and I don't know one of them, so I'm going to connect them. And remember how I always just get you to write down the 4, not the 5. So what connects US, A, and V? V squared is u squared plus 2as. So we get 0 equals y squared minus 19, well, let's just do that slower, minus 2 times 9.8 times 42. And so then y comes out as, I believe y is then 28.69146, blah, blah, blah. Is that right? Well, that's what I've got. And then we're also going to find out what t is equal to. Now, we could find t from here to here. That's perfectly fine. Why don't we just do that? There's many, many, many ways you could solve this. If you've done it differently to me, then who cares? We're going to find out what t is. What should we use? Which looks like an easy equation to use? V equals u plus at. I agree. So we get 0 equals y minus 9.8t. So t equals the value that we've got on our calculator divided by 9.8, which is 2.9277, blah, blah, blah. So we've now found out how long it takes to go from here to here. Now, if you wanted to, you could double it to find out how long it takes to go from here to here. Or alternatively, what could I do with the horizontal distance? I could just half it because I know that that's how far it goes in that bit there. So horizontally, we know that the speed is x. We know that the time is 2.9277 blah, blah, blah. And we know that the distance is a half of 196, which my brain is not up for right now, which is 98. And speed is equal to distance over time. So we get... Sorry, this is taking me too long. We get that x is 33.4733, blah, blah, blah. Now, they want us to find out what u is and what alpha is. So going back to this idea that we've got here, we can see that alpha is the inverse tan of x over y, which we can go straight into our calculator because hopefully we've got these values of x over y. Am I in degrees? Yep. And we should get 49.4 degrees. If you feel like you've done a lot of rounding, what do I usually recommend doing with the answer? Save it with the calculator. Or if you're in a rush and you don't want to save it in a calculator, what's something you could do at the end of a mechanics question just to make sure that your rounding isn't a problem? Say that again? Good. Just round it to 2 significant figures. If you think like, oh, I kind of rushed there and I've rounded everything a bit haphazardly, just put it as 49 degrees instead of 49.4 and then you'll still get it right, okay? So we found out alpha by using the triangle, and then the other option to find out what u is, well, u will be the square root of x squared plus y squared. And you don't even need to write those numbers in there because you've got x and y written elsewhere on the page. So then we just get 28.69146 squared plus 33.4733 squared. Root the answer, and we get that u is 44.1 meters per second, which you might like to say is just 44 meters per second to 2 significant figures. Now, I'm hoping that's the right answer. Is that the right answer? That was the right answer. Yeah?
So,
yes.
You know when you find alpha?
Yes.
Well, can't you just do u cos alpha is equal to one of the values that you found and then u in?
That's exactly what you can do. So we said that u sine alpha was the y value, which then was 28.69. And we said that x was the u cos alpha, which is 33.47. So it's exactly the same thing. All I was saying that at the beginning, you may like to call it x and y because here the equation has just got a y squared rather than a u squared sine squared. And I just know kids who are doing A-level, some people just don't like having u squared sine squared written. They'd much rather just have like a y squared written here, and they'd just rather have an x here rather than a u sine alpha, because you just get confused of what you're trying to find if you're writing u sine alpha and u cos alpha. You're like, oh, but I can't find out what alpha is. I can't find out what u is. So it's just a little tip, I think, that can make things more simple. But did you get the right answer?
I think I tapped in my calculator.
That's always the first thing I check with you. Have you typed it in the calculator correctly? Were there any other ones we wanted to have a look at?
You know with this one, you
Yeah.
you have to find t, but in either the full range or in the maximum height. So you have to somehow link t between them both.
So you have to have t to link them to both, because the only thing, if you think about the horizontal thing, all we know is the distance. We don't know the speed. So we need to do something for the other value, which is time, because remember, you've only got 3 things to choose from for horizontal, and time appears in both of them. So that's why you can either do the time from here to here with 98 meters, or the time from here to here for 196 meters. Okay? So we're going to have a look at another question. I'm surprised no one has brought up another question.
I have questions, but they're like the theory of what they're asking.
Is it one about finding the speed of it at a particular point?
Yeah, they use a time of flight, but that wouldn't make sense because the time of flight is how long it takes to get from one end to the other.
Yes.
But you can't use that if it's
Which, can you tell me which question it is?
16, I think that's the basketball one.
So the basketball one, I think, is going to be a similar thing to what we just looked at here. The one I thought that people might have asked me about, which doesn't matter if you didn't, was... Yes, we're going to do them in class now. Which was the one I thought we were going to ask about? I can't remember. The vectors one, actually, I think is probably one I was going to have a look at. But the only difference about the vectors one that I think might have put people off is the vector question just says it begins with a speed of 1224. But all that means is it's got a speed to begin with of 12 along and 24 up. So you don't need to do any resolving at all. It's already pre-resolved. But the thing that's hard about it is, I think, part B of the question. Should we quickly do question 8? I think we should just go on with the example because I think it might help us to do question 8 anyway. Part B, the speed of it after 3 seconds. I'm going to do a question now that will tell you exactly that bit, and I'll point it out for you as well, okay? So the particular thing I want to have a look at now, back on our booklets, is finding the speed at a given point. And in question 8, it says, find the speed of p after 3 seconds. So it's not asking you to find the speed at the beginning, it's asking you to find the speed at a particular point on the journey. That's what it said in question 8. And you can see the little subtitle I've given for this section is we're going to find the speed at a particular point of the journey of something. Now this is all coming down to the idea of, we know as you move across, can you just remind me what we know about the horizontal and vertical speeds? What do we know? The horizontal is constant, they are independent of each other. So as you go across, we're always forced to keep whatever our horizontal speed is never going to change the size. So that's one of the things we're going to bear in mind when we think about this kind of question, okay? Let's actually read it before we go too deep into what the theory is here. In this question, use g equals 10. They love to just do something a bit different like that. G is equal to 10 in this question, so make sure you don't use 9.8. An object is projected with speed u meters per second from a point A at the top of a vertical building. The point A is 25 meters above the ground. An object is projected at an angle alpha above the horizontal where tan alpha is 5/12. Okay, we can see everything on the diagram that it's saying. The object hits the ground at the point B, which is at a distance of 42 meters from the foot of the building, as shown in the diagram. The object is modelled as a particle moving freely under gravity. Okay, well that entire body of text is just a diagram. There's nothing that we need to read in there that's telling us anything. So we're going to try and find out the value of u, the time taken by the object to travel from A to B, and then part C is the thing that I'm interested in. This is the thing that I think is different to what we have done previously. It says find the speed of the object when it is 12.4 meters above the ground, giving your answer to 2 significant figures. So let's actually just kick off with some of these things that we've got here. Now, because it wants us to find out what the value of u is, and we know that alpha, they said that tan alpha is 5/12. Do we think we can go straight in and say what sine alpha is? Okay, let's draw it. Alpha, what goes here? 5, 12, 13. Sine alpha? 5/13. And cos alpha is 12/13, okay? I guess I know when I say tan alpha is 5/13, I think of TOA, and so I know O is the one that goes with sine, and A is the one that goes with cos. That's how I sometimes do it without a triangle. So running along the bottom here, these are going to be quite quick because we've done some of these already, would be U cos alpha, so 12/13 U. Running up the side here would be 5/13 U. And we can consider both of these motions, and the bridging value is still going to be t that will take us between them. So I think I'll probably start off with the vertical motion. Luke, can you tell me some things I know about the vertical motion? And telling me which direction you're going to take as positive. Mehek, concentrating please.
Down as positive.
You're going to take down as positive, okay?
And then U is U.
We're talking about vertical motion though, so careful.
Oh, U is minus 5/13.
Good, it's minus 5/13 U. This is like the naming variable, and this is actually the variable we're saying that it is, okay? Anything else?
Yeah, A is 10.
A is 10, agreed.
T is something that we need to work
T is what we need to work out. It's the bridge. S is not 0. S is 25. Because it's positive. So we're going to have two unknowns here, aren't we? We're going to have a T and we're going to have a U. Is that going to be a problem? It is a bit of a problem, but it's not going to be a major problem because we'll do simultaneous equations. I'm sorry, you were saying simultaneous equations. I just didn't hear you. So let's just put this together, and it's the classic one that seems to be coming up time and time again. It is S equals ut plus a half at squared. I'm hoping no one has to look these up each time they use them. So we get 25 equals this one, which is minus 5 over 13 ut plus a half a, which is 5 t squared. Okay, I'm just going to kind of leave it at this stage here because it's looking like a potentially going to be quite messy to try and do any solving. I've got two unknowns, so I'm just going to leave it at that stage. I'm now going to have a look at my horizontal motion and think about what I can connect with the horizontal motion. So my speed, and I always write these out as words so I don't get confused with Suvat. My horizontal speed is 12 over 13 u, and my horizontal distance is 42, and my time is t. What do I know about this time and this time? They're the same time because it's the same journey from here to here. It's in the same place at the same time, okay? So I want to find out what t is. And t is equal to, what's t? Speed over distance, distance over speed? Distance over speed. So it's 42 over 12 over 13 u. Now this is where people make lots of mistakes because there's a fraction inside a fraction. What should I do to this fraction here to simplify that? Good. It's going to be 13 times 42 over 12u. I've multiplied the top and bottom by 13. What people often do is they suddenly put that u with the 13 instead, and they multiply by u, and it just all goes wrong. So be really careful when you do this. We've clearly divided by u, so we need to keep u on the bottom. What is 13 times 42 divided by 12? 45.5 or 91 over 2, right? Yeah. So we get 91 over 2u. Keep the u on the bottom. That's where the u has got to be. So now I've got to that stage that we have here. I'm going to sub it back in. So it's a different kind of simultaneous equation. I'm going to sub into here. So we get 25 equals minus 5 over 13u multiplied by 91 over 2u plus 5 times 91 squared over 2u squared, which I'm going to write as 4u squared, because you've got to make sure you square the number as well, okay? This is good. This is looking like it's going to work out quite well here. Can you see anything that I should be doing as I'm coming across here to sort out? I'm going to cancel the u's, they're going to cancel, and now I'm just going to start working out what some of these fractions simplify to. So I have minus 5 multiplied by 91 divided by 13 divided by 2. So I've got minus 35 over 2. And then here I have 5 times 91 squared divided by 4. How unpleasant. 41405 over 4u squared. So take that over. So that's 85 over 2 equals 41405 over 4u squared. I'm going to bring it up here so I've got a little bit more space. Solving this equation, I'm going to move everything all around. So I get 85 over 2 u squared equals 41405 over 2. So u squared, over 4. 41405 over 4 times 2 divided by 85. So I think it's 8281 over 34. Is that what anyone else has got? And then I'll root that. And u is equal to 15.6 meters per second. Nothing new, just a little indication you can do some more challenging kinds of simultaneous equations here, right? And then we just want to find out the time taken by the object to travel from A to B. We've already got we already know that t is 91 divided by 2u. So t is equal to 91 divided by 2u. Well, I've already got u sat there on my calculator, so I can just do 91 divided by 2u, and you get that t is...
0.609.
I got something different. Have I done it wrong?
No, the mark scheme says 2 point.
I think it's
Oh, no, wait, I did 19, not
2.92
Yeah, sorry.
seconds to 3 significant figures. Okay? That's the bit that is nothing new. It's just like a kind of recap of all of these ideas. This is the bit that I'm interested in. This is the bit that's new, so let's keep our concentration as much as on as we can do here. It says, find the speed of the object when it is 12.4 meters above the ground, giving your answer to 2 significant figures. So I'm going to refer back to my diagram for a second, and I'm going to think about where that 12.4 meters above the ground is. Okay, well, 12.4 meters, roughly somewhere in the middle. I want to know how fast is it going at this particular point that we've got here, where this distance is 12.4. Tell me something about how it's traveling at this time. Okay, so it's coming down at this angle, right, like this, and it's actually traveling at a tangent to the curve. Okay, that's what the speed is. It's going at a tangent to the curve. Tell me more about its speed. I want you to tell me anything about its speed at that point.
It's still getting faster.
What do you mean it's still getting faster?
Accelerating.
It's accelerating downwards.
Yeah.
Okay, so tell me something else about its speed, please. The horizontal speed is constant. Do we actually know what the horizontal speed is?
Yeah.
We could work it out, couldn't we? Very, very, very quickly, because we know the horizontal speed is 12 over 13 times 15.6, which is what u was. So over here, I know it's travelling across at 12 over 13 u. I want to find out how it's travelling down at this time now. If I know how it's travelling across and how it's travelling down, what could I do with those two values? Pythagorize it. I could put them back together. So when they ask this question of finding the speed at a particular point, what they're actually saying is find the vertical speed and then incorporate the horizontal speed with it. That's what they're really asking you to do. They're trying to get you to notice you can put them back together using Pythagoras. This question doesn't mention it, but they might say to you, what's the angle that it's travelling at that time? How would you find the angle that it's travelling at? You just do trig, because you've just got a triangle here. You've just got this and you've got this. You would find the angle at the top, and you would say it's travelling below the horizontal at that particular angle. So we're going to go and try and find out this thing. This is the thing that I'm interested in to find out what its vertical speed is. So first of all, for part C of the question, we can find out what its horizontal speed is. Let me know if I'm going too fast. This morning I think I was going very, very fast. So the horizontal speed is this u value times by 12 over 13. So it's 12 over 13 times by u, which is 14.40588. So it's more than enough numbers to write out if we're going to be rounding it to 2 significant figures anyway. Now we're going to try and find out what the vertical speed is. So I'm going to consider vertical motion. Which direction do you want to be positive at this one? Down. Okay, let's do down as positive. What do I know about down? Tell me some facts. A equals 10. S equals 12.6. Very good. I was wondering if anyone was going to notice that. Why is it 12.6 and not 12.4? It's asking for 12.4 meters above the surface, and the displacement has me going on and on about, oh, if you took a photo of it here and then a photo of it here, you would have said it moved 12.6 meters from here to here. It's really annoying. 12.6 down, but 12.4 up. So very well done for noticing that. Did anyone else notice that? You didn't. You did. Okay. I'm telling you right now, you're going to have a question that's like this, possibly in a mock exam. I've seen a question, they talk about it being throwing it into the sea, and they say, when is it? What's the speed 5 meters above the sea? Everybody uses s equals 5. S isn't equal to 5. S is the difference between them. So very well done for spotting that, okay? What else do we know? U is the one we did before, which was minus 5 over 13 u, and we know what that is. And we're trying to find out what v is, aren't we? So v squared equals u squared, which I better figure out what that was. So it's this one times by 5 over 13. I think it's 6. This is actually 6.00. So it's going to be minus 6.00. Minus 6.00 squared. That's v squared equals u squared plus 2 times a times s. So putting all that in our calculator by squaring and adding this. When you square root it, you should get that v is 16.9714. Just from solving the equation, okay? So as a diagram, what this looks like, if we just refer back to what we'd got written here, it was going across, I think we said, does anybody remember what I said it was, a 14 point something? I'm going to have to keep going up and down on my page, which I don't like doing. 14.4. So it's going across 14.4 and it's going down 16.97. So when we come back to this, across 14.4, down 16.97. The hypotenuse is u. Well, not u, it's going to be v really, isn't it? Apologies, making a mess. So we'll do the square root of 14.4 blah 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 squared plus 16.97 blah 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 squared. And luckily we just want it to two significant figures and you get 22 meters per second to two significant figures. Okay? A couple of things that I would check to see about if this answer makes sense. It's travelling at 22 meters per second here. What was it initially travelling at? 15.6. Does it make sense that it is travelling at a faster speed there? Yeah. What would its speed be here? The same as what, Luke? Which is what? 15.6. It would be 15.6 here, so it makes sense it's travelling faster here. Just to, if you get an answer and you got like 12 as your answer, you should be saying to yourself, this doesn't make sense. Something has gone wrong here. So I'm not going to be able to show you every which way that they could ask you this, but they might ask you about the angle that it is as well. So that question 8, which was a vectory question, when it said find the speed when t is 3 seconds, well, you know the horizontal speed already. They're really asking you to find out the vertical speed and then to Pythagorize. Please don't ever use the word Pythagorize outside of the class, okay? So were there any questions about this bit? Sarah? Yes. Yeah. It's a hard topic and it's only a 2-lesson topic as well. So what you're going to then do for me now is you're going to try this question here, okay? Part A and B, I think, are all fine, but part C, it's asking you to find the speed at a particular point. So that's the idea of you using that speed at a particular point that we get to. And then I think you've got another exam question in here as well, which has got something really interesting in for part C. So we've got 2 exam questions that's probably going to take us, I should think, maybe about half an hour. And then we're going to come back and finish the topic off today. And I'm going to come around now and just have a look at your work that you've done. Okay? Things to look out for this one is it's got an angle of depression at the beginning. So it's going to be going along and down, not along and up.